Hi everyone. Audio both are clear everyone, all of you. You just observe. Somebody just check it. Audio both are clear. Right. So we'll be continuing our discussion on this. Which one? This all formula revision. Right. All formula revision of what? All formula revision of this highway engineering. Now we'll be discussing if we just observe all formula revision of this highway engineering. You can say it's now. Right. By myself. Now, all of you, welcome to Unacademy. Let's crack it, right? Yes, Sabana. Good evening. Good evening, guys. Yes and Sabana. Right. How are you guys? Had your dinner? Yes and Sabana. So, all of you. So, this one, all of you, welcome to Unacademy. Let's crack it, right? Are you all guys ready to crack? Yes, everyone get ready to crack, right? Everyone get ready to crack, all of you. Yes, everyone get ready to crack, right? So whenever you are subscribing for the plus and iconic courses, right, what is the referral code you have to use? RP Civil Live is the referral code you have to use always, right? RP Civil Live is the referral code you have to use always if you just subscribe, right, like that. Yes, you are fine. Dinner is also done. Yes, very good, right? So GATE and ESE Civil Engineering, right? So this is my profile. You can follow me at which, and if you are already following my profile in Unacademy, just check it. Share my profile link with all your friends. And RP Civil Life is my referral code you have to use whenever you are subscribing for the plus and iconic courses. Okay, these are all the plus courses I'll be taking, right? After a long time you are live today. Yes, absolutely. Now today and tomorrow, right? Today and tomorrow, only these 2 days you are having this offer. Unlock 20, right? 20% unlocking you have to do, right? So whenever you are using the RP Civil Live code previously, you will be getting this 10% discount only, na? But for today and tomorrow, right? But for this today and tomorrow, what is that you are getting? You will be getting this 20% discount, right? It is not the 10% discount, right? You have to be careful, right? So just whenever anybody is willing to subscribe to the plus and iconic courses, subscribe ASAP, right? Before this offer gets over. Iconic subscription, these are the benefits you are having, right? These are all your mock tests you are having, is na? So today was the last test on this last mock test in the by Unacademy you are having, right? So these are all the new batches starting. These are all the new batches starting. If you just observe all of you, these are all the plus courses and free courses I'm taking, right? Like that. And now we'll be continuing our discussion on this. We'll be just going to which one? This current session. What we were discussing, if you say in the last session, what we were discussing, that spacing of this, which one? This is spacing of this contraction joints we are discussing, na? Yes or no? Spacing of this contraction joints and length of this tie bar, right? Expansion joints, it's not design of this expansion joints, right? Design of this expansion joints and design of this contraction joints with dowel bars and without dowel bars, right? Like that, isn't it? And the longitudinal bars we have seen as na longitudinal joints, and on the longitudinal joints tie bars, length of this tie bars and spacing of this tie bars, and specifications regarding this length and spacing of these tie bars also we have seen na. Yes, these are all the few things we have seen in yesterday's class. If you just observe it like that, it's not 294. Now in today's class, right, this lesson 32, we'll be completing this payment and we'll be entering into this topic. You can say we just observe it like that. Okay, 294. This is your 295. What is the 295? You can say if we just observe, all of you. What is that you can say if we just observe, right? Whenever you are designing, right? Whenever you are designing which one? Whenever you are designing this, right? Whenever you are designing what? You can say whenever you are designing this dowel bars, right? How to design this dowel bars, all of you? How to design these dowel bars? Anyone having idea how to design the dowel bars? Right, that design of this dowel bars we'll see, and after that we'll be entering into that, right? Okay, right. So whenever you are having this, right, what is the design of this dowel bars? You can say if you just observe, these dowel bars are coated generally with what? These dowel bars are generally coated with what? Coated with zinc or lead. Coated with zinc or lead, or you can also be coating with which one? Or zinc or lead based paints, right? Zinc or lead based paints. Zinc or lead based paints, or you can also coat them with which one? Or epoxy coated, na? Or epoxy coated. epoxy coated, right? Epoxy coated, you can say it like that, isn't it? Right? So then what is it you can say here? Whenever that double bar is placed here na, because this is your expansion and the double bar is placed na, so here how much bar is embedded into the concrete and how much bar is left outside? So this much you can say, right? This side some bar, this side some bar portion is na, so half of the portion must be inside and half of the portion must be outside, you can say, right? Like that, isn't it? That's 296, right? Why we are coating them with that? If you just observe, we are coating them with that to take care of what? Yeah, Sabana, already this 294 formulas done na. Starting onwards, we are just giving the formula numbers, right? One formula or whatever it is the important point, right? 1, 2, 3, 4, 5, 6 we are giving. This is 294th one was done in the yesterday's class, and today's one is 295th formula or concept, right? Either it is a formula or it is a concept, okay? Is it clear? Yeah, Madhav, yes. So is it clear? What is the 295 number? What is the 295 number is representing? Is that clear? 294 formulas are discussed till yesterday. Formulas are simple concepts, right? Now 295th concept and the next one is your 296th concept. You can say it like that. Is it clear? Right? So here what is it you can say? Half of this length this is also asked in some of the examination, right? Half of this length, right? Half of the length. Which length? Length of this double bar na? Half of the length of this double bar. Half of the length of this double bar is which one? Inserted or embedded in concrete. Embedded in concrete firmly. And what else you are having, right? And what else you are having, right? Why you are coating them with zinc or lead based paints? Because to take care of this which one, this corrosion only, no? Yes, right? Half of the length of the double bar is embedded in concrete firmly, and the remaining half portion, right? And the remaining half portion, what you are doing? And the remaining half portion, what you are doing? Remaining half portion kept free. Remaining half portion is kept free for which purpose? Kept free using what? How you are keeping it free? Using a sleeve. Yes, now using which one? The sleeve, right? Using a sleeve for a free movement, right? For which one? For a free movement in other slab. For a free movement in other slab, right? So means in one slab that half portion will be kept tightly, and in the other half, so what is it you can say? It is freely kept, right? It is freely provided, right? So what does it mean is, this is your left side of which one? This one panel, you can say this is one panel, and let us say this is your which one? This other panel. If you just observe, whenever you are considering this reinforcement bars, double bars, right? This is your double bar, you can say. If you just observe, whenever you are keeping this double bar like this, what happens, right? This one side, this is fully covered with which one? This concrete, right? This concrete reinforcement, concrete which one? This bars, concrete aggregates will be there and everything will be there. It is held firmly. But other side, what you are doing? If you just observe, the other side we are just keeping some sleeve like this. We are just keeping some sleeve like this, right? Because of this sleeve, what happens? Because of this sleeve, what happens? Because of this sleeve, what happens, right? And these aggregates will come beyond that sleeve, right? Not only because of this sleeve, that double bar is freely moving into the other slab, na? Because of this sleeve, that double bar can move freely into the other slab, or not all of it? Yes, it will be moving freely into the other slab. If you just observe it like that, you can say. Why? Whenever that wheel load is applied onto this, that wheel load will be transferred and it is dissipated by means of this sleeve only. No, it is better we have to provide this sleeve or not? Obviously, yes, it is better we have to provide this sleeve, right? Is it clear that sleeve how it is helpful? Now we'll move on to the next point, 297th one. So is that clear, that point, everyone? What is that you can say? Design load for this double bar, right? What is the design load for this double bar? So there are different axial loads we are having. Now what is the meaning of this axial? It is just a combination of these two wheels is called as your axial, right? Left wheel and right wheel are connected together by means of which one? This axial, you can say, yes, na? Right. So here design load for this double bar is equal to what? Design load for this double bar is equal to which one? This it is 40% of what, right? 40% of this maximum axial load present. So whatever the maximum, different axles are having different loads, different vehicles are moving on the road with the different axial configurations with the different axial loads, right? Whichever the axial configuration is having that maximum, you can say that is which one? That is that axial load we have to select, and 40% of that axial load will be used for design, used as a design force of which one? This double bar, you can say, right? Like that. When these are not recommended, if you just observe, these double bars are not provided, right? These double bars are which one? These double bars are not provided when these are not provided. If you just observe, these double bars are not provided for slab thickness, right? What is the meaning of this slab? Concrete slab only, no? Yes, for a slab thickness of how much? For slab thickness lesser than 150 millimeters, only for the slab thickness greater than or equal to 150 millimeter, these are provided, right? Double bars are recommended, otherwise don't provide them. It's not, is it clear? Right? So who will be responsible for that? Who will be responsible for transferring the loads? You can say the bearing stresses in the concrete are responsible for the performance of the joints for the double bars, no? So no, who will be responsible? You can say the bearing stresses, right? You have to be careful, right? Bearing stress in concrete. The bearing stress in concrete, right? Bearing stress in concrete, right? Whenever there is a load transfer, these double bars are used for which purpose? To transfer the load from one panel to other panel. Otherwise, if double bars are not there, this panel will deflect like this, other panel will not deflect, right? And to avoid this differential deformation, when double bar is provided, load is transferred from one panel to other panel, and it will be deflecting like this, na? Like that. So in this, what is that? You can say bearing stress in the concrete is which one? This mainly responsible, right? Is responsible for which one? It is responsible for which one? This performance of joint. It is responsible for the performance of what? Joint for the double bar. Like that you can say. So this is what you are having, right? That is which one you can say if we just observe it. That is which one you can say if we just observe it. Bearing stress, right? What is the bearing stress? You can say that is sigma b maximum. What is the bearing stress, right? This bearing stress is sigma b maximum, right? Between the concrete and the double bar, it is given, right? How much it is? How much it is given? This is your bearing stress, right? Bearing stress between which one? This concrete and reinforcement, na? Between this concrete and reinforcement, reinforcement or whatever it is, a bar you can say, double bar, right? What is it? You can say that K into that PT into that 2 plus beta Z divided by how much? You can say that 4 beta square EI, right? What is that beta? You can say we just have that KB divided by this 4 EI. KB divided by this 4EI whole power which one? This 1 by 4, right? Like that, right? 1 by 4, right? This is the expression for which one? This bearing stress present between what? Bearing stress present between the concrete and the double bar, right? Bearing stress present between which one? This concrete and the double bar, you can say, right? This is the bearing stress present between the concrete and double bar, you can say, we just observe like that. It's not. Now what is that beta, you can say? What is the meaning of this beta if you just observe? That beta is nothing but your relative stiffness of the bar embedded in concrete. How you are calculating? Like this. It's not KB by this 4A. It is which one? It is a relative stiffness. The relative stiffness of whom? Relative stiffness of the bar embedded in concrete. What is the K, you can say? K is nothing but your which one? This modulus of Dowell. Modulus of which one? This Dowell or concrete interaction. It is not the modulus of subgrade reaction. You have to be careful. It is not that modulus of subgrade reaction. It is different, right? What is that B? You can say that a B is nothing but your diameter of this double bar. So it is given in terms of which one? This MPa per meter. What is that B? Diameter of this double bar. In terms of which units we have to write? That millimeters you can write. And what is that Z? You can say that Z is nothing but your joint width, right? Whatever it is a gap you are having, right? If it is a contraction joint, it is a 0. If it is an expansion joint, you are having that gap, na? So no. What is that E? Capital E is nothing but your elastic modulus of this double bar, na? Elastic modulus of which one? This double bar. What is the I? You can say I is nothing but your moment of inertia, right? Moment of inertia of which one? This double bar. What is that P suffix T? If you just observe it, this one P suffix T is only left, na? Yes or no? P suffix T, K we have seen, beta we have seen, Z we have seen, yeah, everything we know, B we know, right? What is that PT? Load transferred, right? What is it? You can say that load transferred by a double bar in kilonewton. Load transferred by double bar in kilonewton. Like that you can say, right? So this is about your which one? This bond stress, bearing stress developed, right? Bearing stress developed between which one? This concrete and the double bar during the transfer of this load PT, right? During the transfer of this load PT, this much amount of this bearing stress is created, right? Like that. So now tell me, do you need to select this as it is, or we have to check it with this permissible stresses? We have to check this with the permissible or allowable bearing stress, na? Yes or no? Allowable, right? That is a stress generated, but it has to be compared with which one? This allowable stress, na? Allowed, right? Allowable or allowed. What is it? You can say allowable or permissible. Allowable or which one? This permissible bearing stress. In which one? Concrete, no? What is it? Permissible bearing stress in concrete? You can say that FB will be equal to, right, 101.6 minus B, right? What is that B? B we know, diameter of the double bar, na? Just now we discussed, na? Divided by which one? This 95.25 into what is that? You can say that FCK, right? FCK is nothing but your grade of the concrete. B already we have mentioned that the diameter of the double bar. You can say, we just observe it like that, isn't it? FCK is a characteristic strength or grade of this concrete which we have used. And what is this? B is nothing but your diameter of this double bar, if you just observe it like that. Is it clear, everyone? Right? 300, now 301. What is that? You can say, if we just observe. Suppose this is one panel in plan, right? In plan we are telling this is another panel in plan, you can say. These are the double bars you are having. Now tell me, do you give guarantee that these double bars will transfer all the wheel loads present, or they will transfer the wheel loads nearby this double bar only? They will transfer the loads only which are nearby the double bar, na? Which are only nearby the double bar, right? Means within, if it is lesser than or equal to L, right? So this load will be transferred, this load will be transferred, this load will be transferred, but these loads will not be transferred, right? These loads will not be transferred. What does it mean? You can say, it means that, right? It means that it will be transferring loads within a distance of this small L from the double bar, na? Whichever the loads present within a distance of this small d from the double bar, those loads only will be transferred, right? Other loads, will they be transferred or they will not be transferred? Other loads, they will not be transferred. You can say, we just observe it like that, isn't it? So what is the point? You can say double bars will transfer. What is that L? Radius of this relative stiffness. Yesterday we have given a EH cube by 12k into 1 minus mu square whole power 1 by 4 dB. For yesterday we have given that formula, na? Yes. Double bars will transfer. Double bars will transfer loads within a distance of what? Loads present. Loads present. Dowel bars will only transfer, right? Only transfer loads present within a distance of small l from them. From these dowel bars, if the loads are present within a distance of small l, they will be transferred. Right? If they are beyond this small l, they will not be transferred. If you just subtract a few, right? Like that is clear, everyone. So this is what, right? 302. You can say if you just subtract off. What is the 302? You can say. What is the next one? You can say. Right. So here, if you just observe it, whenever you are having this sub base and the payment, so here let us see if we just observe it, a micron polythene sheet is provided, right, to take care of this mud pumping. To take care of which one? To take care of what? Mud pumping. To take care of this mud pumping, what is that we are providing? A separation layer. Layer of how much size? 125 micron, right? 125 micron polythene. (125 micron polythene sheet is which one? This provided, you can say. Provided, where it is provided, if you just observe it, where it is provided, if you just observe, it is provided between which one? This is sub base and payment slab. So this is your main slab, right? Have you observed this black color payment? If you just observe, anyone, have you observed this black color polythene cover below this cement concrete? Below this cement concrete, whenever they are constructing this cement concrete pavement, right, have you observed this black color plastic cover? This is your 125 micron, right? So below this sub base you are having, right? Below this, what is it you are having? This base, it is present, you can say. Base or sub base, whatever it is present, you can say. Have you observed this, right? This is your 125 micron, that polythene sheet, right? That is your 125 micron, that polythene sheet, you can say, if you just observe it like that, isn't it? Isn't it? You observed, right? Very good. That black color plastic sheet is nothing but your this separation sheet, right? 302, no, 303, right? If you just observe it like that, what is the next specification, you can say? What is the next specification, you can say, if you just observe, right? So here the next specification is what? Fatigue, right? Fatigue behavior, right? Whenever you are observing fatigue life, rutting is not there, mud pumping and fatigue are the failures here. But in case of flexible payment, rutting and fatigue are the failures. So rutting life and fatigue life we have seen it. But in case of this rigid payment, what are the failures? Rutting is not there, only fatigue is there, and as well as this mud pumping, right? To take care of this mud pumping, that polythene sheet is provided, and to take care of this fatigue, we have to check it, right? Fatigue life, right? What is it? Fatigue life, you can say. Fatigue life is nothing but your it is the number of equivalent standard axle repetitions required to create this fatigue failure, right? Fatigue failure, you can say, right? It is based on what? This stress ratio. What is that stress ratio, you can say, if you just observe? Stress ratio is nothing but your flexural stress. Stress ratio is nothing but your flexural stress due to what? Loads divided by which one? Stress divided by this strength, right? Flexural strength of concrete or bending strength of this concrete in tension or compression. In tension, obviously, na, because fatigue is nothing but your, whenever load is applied, it will deform like this. Load is removed, it will move like this. Load is applied like this. Load is removed. Whenever this kind of situation is happening, cracks are generated and tension only, right? Stress ratio, right? Stress ratio, if you are just calculating, right? So now tell me, what is the fatigue life? If that it is that fatigue life is depending upon the stress ratio. If that stress ratio is lesser than this 0.45, if the stress ratio is lesser than this 0.45, What is that fatigue life? N, you can say unlimited. What is the meaning of this unlimited? Within the lifetime, how many number of standard axles you are allowing, or how many number of vehicles you are allowing to move? Do you have any fatigue failure or no fatigue failure? You require unlimited number of standard axle repetitions to cause fatigue failure. Is that unlimited practically possible? Not possible. So means fatigue failure will never occur in this manner, right? Or if the stress ratio is which one? If the stress ratio is in between, right? If 0.45 lesser than or equal to that stress ratio is lesser than or equal to that 0.55, that is second condition, right? Third one, if that stress ratio is this greater than 0.55, third condition you can say, right? Second condition, what is the fatigue life you can say? That fatigue life N is equal to 4 point which one, that 2577 divided by this stress ratio minus how much? 0.4325 whole power how much? 3.268. That is your fatigue life, right? And here if the stress ratio is greater than 0.55, what is the fatigue life N given? That is given as your log N to the base 10. Log N to the base 10 is given. Or shall I write that directly N value? Yes, I'll write that directly N value, it is better. N is equal to how much? That N is equal to 10 power. 10 power how much? 0.9718 minus this stress ratio divided by how much you can say? 0.0828, like that. So this is what you are having, right? What is the fatigue life consumed then? This is how we are calculating the fatigue life. If you just observe, right? 303, now 304. What is the fatigue life consumed? What is that fatigue life consumed, all of you? That fatigue life consumed is equal to expected repetitions, right? What is the expected repetitions in lifetime? Expected repetitions are nothing but your, can we say, expected repetitions divided by this fatigue life. What are these expected repetitions? Cumulative number of standard axle repetitions expected only now divided by this N, right? If it is lesser than 1, what is that you can say? If it is lesser than 1, that payment is safe. If it is greater than 1, what we need to do? If it is greater than 1, what we need to do? It is your unsafe, you can say, right? So whenever it is unsafe means that payment is sufficient, or we have to change the thickness, right? Payment is unsafe means we have to go for the next trial and we have to check the thickness of this payment. If you just solve it like that, is that clear everyone? Is not? So design of this payment, right? Design of this payment is which one? Design of this, right? Design of this payment, right? Design of this payment is which one? It is just a trial and error procedure, right? It is just which one? This is a trial and error procedure only, right? So first we need to assume some thickness and we need to check it, right? First we need to assume some thickness and check it, right? Is that clear everyone? Right? So now actually we have missed something, right? What we have missed something, if we just observe. What we have missed something, if we just observe, we have missed the resultant stresses, right? That resultant stresses we have missed somewhere, right? In our after writing that stresses now, we have missed that resultant stresses writing. Okay, that we'll write here 305, or shall we write there itself? It is better we'll try to write there and there itself, right? I did not write that. What I have shown, that stresses, right? Different stresses I have shown, but after that immediately I have entered into the joints. Day before yesterday's class, right? So what are this you can say? Wheel load stresses at corner, individual, right? Nature of this stresses and amount of stresses, each and every individual formula we have seen, that. But what we did not see, if we just observe, we did not see this, right? We did not see this. This is your 288 now. So we'll write that 288 formula only. We did not write that resultant stress formula, right? For a design, only one stress will occur, or all types of stresses will occur? Obviously all types of these stresses will occur na? So whenever there is a resultant stress, how to write, how to calculate the resultant stress, we'll just see now. Okay, all of you, I'll just show it here. Resultant stresses. Okay, you can write it here itself, or you can write it then and there also, at the end also, no problem, right? For edge, whenever it is edge, so this is your 288, means this is your 288a, okay, 288a, right? Resultant stresses, right? First one is your edge or interior. Whenever it is at edge or interior portion, at edge portion or this interior portion, at which conditions are critical? Always for this edge or interior portion, the critical stresses will be which one? This at the bottom only, right? Always you calculate the resultant stress at the bottom only, right? So because we will be taking that tension as a positive, will be taking that tension as positive, and will be taking that compression as which one? This negative, right? Because this concrete is weaker in tension, so tensile stresses are critical, obviously, or not? Yes, tensile stresses are critical, so we'll consider tension. So what is that first and foremost condition? You can say summer midday. Whenever it is your summer midday, what is that resultant stress? Resultant stress at the edge will be V load stress at the edge plus this warping stress at the edge, right? SWA minus this, which one? This frictional stress at the edge, you can say, right? Now interior, resultant stress at the interior is equal to plus positive V load stress at the interior plus positive warping stress at the interior and minus frictional stress at the interior, right? Like that you can say, right? Summer midday. Whenever it is summer midnight, if you just observe, whenever it is at summer midnight, for summer midnight, right, what is the, you can say that resultant stress at the edge is equal to V load stress at the edge plus this warping stress at the edge plus frictional stress at the edge, you can say. If it is interior also same thing, na? Resultant stress at the interior is equal to positive V load stress at the interior plus positive warping stress at the interior plus positive frictional stress at the interior, you can say, right? Like that. And this is for the edge and interior portions, right? Whenever it is a corner portion, whenever it is a corner portion, what you need to do? By default, you have to calculate the stress at which location? Top location only, right? Top location only, right? Top portion only. And that too, what is the condition to be considered if you just observe? What is the condition to be considered if you just observe? It is your winter midnight, right? Right? Winter midnight, right? Winter midnight, right? Winter midnight, what is that you can say? Winter midnight, right? What is that you can say? It is your winter midnight if you just observe. Is that clear, everyone? Winter midnight conditions, right? Whenever it is that winter midnight condition, right, what is the resultant stress at the corner? It is equal to positive V load stress at the corner plus positive warping stress at the corner plus or minus, right? Minus what is that? Frictional stress at the corner. But this frictional stress at the corner will be 0, right? Frictional stress at the corner will be 0, right? Which one will be taken as the resultant stress, all of you? Whichever is maximum, that will be taken as the resultant stress if you just observe, right? Whichever is maximum among these three, that should be considered for the design purpose, na? Yes, that should be considered for the design purpose. You can say if you just observe like that, yes, na? So this completes your which one? This is a rigid payment. So what is that you can say? These are the things regarding the rigid payment, right? These are the things regarding which one? This rigid payment, you can say it like that. Is that clear, everyone? Is that clear, everyone? Now we have mentioned it. We have mentioned that, right? We have mentioned that it is which one? This a trial and error procedure, na? It is just a trial and error procedure, right? Whenever it is a trial and error procedure, and in the first trial, right, to get the thickness in the first trial, we should have some thickness, na? Who gave this thickness? If you just observe, who gave this thickness, right? There is a formula called as your Goldbeck formula, right? Goldbeck formula, okay? Goldbeck formula for which one? This is thickness calculation, right? With this, rigid payment will be over, right? Thickness of this CC slab. What is that? H is equal to under root 3 times that W divided by which one? This is sigma max. What is that? Sigma max, you can say. This is your permissible stress, you can say. This is your permissible stress, you can say permissible stress in concrete. And what is the W? We can say W is your wheel load. W is your which one? This wheel load, you can say it like that. Yes, na? So this is how that Goldbeck formula will be used for calculating the thickness, right? In the first trial, right? In the first trial, right? Like that. Is it clear? Is it clear, everyone? Is it clear, everyone, all of you? These are the formulas for which one? This is a rigid payment, you can say, right? These are the formulas for which one? This is a rigid payment, you can say. Right, shall I close the session, all of you? So it completes your rigid payment, right? Only we are left with which one? This is a traffic engineering, and February 1st and February 2nd, those two classes will be taking, and with that it will be over, okay? February 1st and 2nd will be taking these classes, and this all formula revision of this highway engineering will get over, okay? Shall I close the session, everyone, now? Shall we closing the session? Thank you all of you. Have a